Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afif Aiman bin Irwan with the metric number is TH20034. And now I will present to you the lab video for this experiment, which is the title of this experiment is the electricity from lemons to light a bulb. The zinc in the nail and the copper in the copper cable react easily with the lemon juice. When the zinc in the nails react, zinc 2 plus ions dissolve in the lemon juice, doubling the quantity of electrons available for movement. These electrons are ready to be accepted by the copper cable. The wire and LED are the quickest method for electrons to travel from anode, which is galvanized nail, to the cathode, which is the copper cable. The flow of electricity is controlled by the LED, which is the full name is light emitting diode. This is why the short lead must be linked to the anode and the long lead must be attached to the cathode for it to work. The electron mix with H plus ions from the surrounding lemon juice as they travel through the circuit to the cable. H2, often known as hydrogen gas, is made up of H plus ions and electrons. When the LED is turned on, we need to look attentively to see if there are any tiny bubbles where the cable and lemon come into contact. The lemon, nail and cable combined form a battery because the breaking and forming of chemical bonds inside the lemon causes the electron to move. Okay, this is the material and apparatus that has been used in this experiment, which is first lemon, galvanized nail, copper cable, alligator clips with wire, clips, LED bulbs, and lastly digital multimeter. Firstly, the lemon needs to be rolled on the tabletop with the palm of the hand to loosen the juice inside the lemon. After that, a slit is cut into one end of the lemon and the galvanized nail is inserted gently and carefully. Although the galvanized nail reaches the inside of the lemon, a small part of it remains outside the lemon to allow the alligator clip to be fastened. The copper cable was put into the lemon through a slit cut in the lemon opposite the galvanized nail, leaving a tiny part outside. The electrodes are positioned opposite each other because the higher the voltage produced by one electrode, the greater the voltage produced by the other. The two charged electrodes will now allow electrons to flow through them. To measure the volt present, two alligator clips were connected to the two electrodes and one of the multimeter terminal was connected to the copper cable and the other terminal to the galvanized nail. When connected in series, the two ends of the alligator clip were connected to the multimeter terminals. Next, the value of the voltage and current was recorded and has been connected to the LED bulb to check the brightness of it. Lastly, repeat the previous step by adding the number of lemon and connect all the lemon with a clip. A clip was linked to one end of lemon's cable and the other end to the galvanized nail of the another lemon, and another clip was connected from the second lemon's cable to the galvanized nail of the next lemon. Okay, this is the safety and precautions that we need to consider while conducting this experiment. Okay, first, we must ensure that the galvanized nails and copper cable are rustless, as this will affect the voltage and current readings. Besides that, we also need to make sure that we switch off the multimeter, because if we don't switch off the multimeter, the readings would be invalidated if you want to use it again in the future. Data has been taken after we connect two alligator clips to the two electrodes where one of the multimeter terminal was connected to the copper cable and the other terminal was connected to the galvanized nail. For the observation, the value of voltage and current will appear in digital multimeter after we successfully connected all the lemon with connection wire and clips. That's all from me. Thank you.